What we see here is my poly handling software. Kind of looks a bit like the stuff I wrote years ago, but it's been upgraded to handle Node-Red sitting in a Docker container. MP3, MBG123 is not sitting in the Docker container, it's just running natively, so is AMixer. Now, AMixer is built into this and the previous version of Raspberry Pi operating system, so I didn't have to install it. I had to install MBG123. That's covered in the blog. AWS POLLY runs in the actual container rather than natively, and that has to be installed. That's also covered elsewhere. Before I give you any indication of how this is working, I'm going to actually play something. So what I'm going to do is I'm going to play something I know I already have. Let's just change this. So this very last inject has something new that is not on the system. All of the rest of these are already recorded. Some are just pre-recorded from, like, Star Trek snippets. Some of them are bits of speech that I put in, like, have a nice day. And the reason I put these was to show you the difference between a statement and a question. So let's show you something that exists already. Have a nice day. Watch what happens here. You will see that this container will not show a status, any status info, because it's not getting called. MPG123 will. And when it's finished, it will clear a flag that says, we're finished playing. So, have a nice day.
Have a nice day.
Yeah? Slight difference will be, are you having a nice day? Question.
Are you having a nice day?
You see the difference in the tone. It's really quite good compared to previous versions. Now, I'll go into this later and show you there is a particular flag for the AWS POLLY that says use the neural engine, and it works very well. So, what else do I want to show you here before we go into how this works? I want to show you what it actually does. So, if I click red alert 3 times in a row, they won't overlap and fail. They'll be buffered. That's the point of my code. 1, 2, 3. You see that? And the same happens with AWS. If I go to record something new 3 times in a row, or 3 different ones, it will queue them up. So, are you having a nice day? This is brand new. It's not just going to come out of the MPG123, it's going to go off to AWS POLLY and get it. You'll see an indication there underneath in blue. When it's got it, it will then go to MPG123. So you have this unavoidable delay while it goes off to get the MP3 file, and that's gonna vary on the speed of your internet connection. So, are you having a nice day? Watch, no sound, then it will go and play this. So, here we go.
Are you having a nice day?
Do you notice that actually sounded like a question? Next time I play it, and from there on, it'll come back straight away.
Are you having a nice day?
So I have lots of recordings like this. Pete, time for your pills, or time to take the cat out, whatever. Got lots and lots that I use. But I'll just put a few samples in here to show you, which in a second I'll switch you over to another screen and show you where they're stored, just to reinforce the directory structure. The directory structure as seen by Node-Red in its container is different to as it's seen by AMixer and MBG123. The flags are simple. There you are. That's just global center flag and return, or global reset flag. So process text. So let me show you the first one here, the volume control. This is really just a nicety. Most of the time I play it at 100%, but if I want to control the volume, see how I've put here weird volume relationship, and it is 50%. I want 30% audio. On my system, I had to put a percentage value of 89 in, and so on and so on. They're not linear, they're really weird, and it may be different on your system. Feel free to mess around with those values. Don't touch anything else, but by all means, 100%, 100, 30%, 77. Play around with those if you need to. Now we come to the more complicated bit. This function, the code in there, handles everything I've told you about buffering, getting the information from Amazon ORs, and playing MPG123 files. I'm going to click on that. Hopefully you see the lot on your screen. So here's my function with everything in. Nothing's changed in this first section. It's as it was years ago. Those global busy flags and the array in which I store information are just zeroed out on first run ever. From there on, this section's ignored. If making sure that I've actually typed something into the payload, push that request onto the array of requests. All right. If there is something in the array, get the first value out. MPEG-3. If this is an MPEG file that we've already noted, we're going to play it. If not, we're going to make an MPEG file. I'm replacing certain characters, any special characters which would just get in the way of things. If there are spaces, as there would be, if I say hello there, I just say hello there. But from a file perspective, I want an underscore between those two words. So that's what that's about. If the file exists, if we're not busy, go to MPG123 and at the actual folder structure address, go and get that file. If we are busy, shove something onto the array. Now again down here, if the file doesn't exist and we want to go off to our OWS Poly to get it, if OWS Poly is already busy, just bang it into the array. If it's not busy, say, right, we're busy, voice equals Amy, go off and call poly OWS CLI poly with these flags and request our text in the form of a file, which Amazon will determine the name of that file and will return it and store it where we want it stored. So the flags here, nothing's changed from my original. The output format is an MP3. Make sure you get these right. If for any reason by the time you see this, you see single minuses here, there are supposed to be double minuses for all of these flags. Engine is neural. Without that, you'll get a very bored sounding poly. Voice ID is voice, that's Amy. Region EU West 2. The reason the region's important is for some reason the neural engine doesn't work in every region in the world. I don't know why, but I put EU West 2 almost arbitrarily. I don't know whether I'm the west or the east of EU. I'm actually in the east of Spain, but that works. I just accepted it, put it in. So what you're going to see here is the full address of the file is where it gets stored. Yeah, root .iot, Node-Red, data, audio, and the file. However, Node-Red, when processing this, sees a different structure. It only sees data, audio. whereas we're actually storing it in that full structure there. Node-Red we see as the data audio. Antonio will be far better at explaining this than me, but there you are, it's all in front of you. So that's it. It's actually not that complicated. The Node-Red in a container made things a bit more complicated, but this has worked for years, generally, this piece of code, and lots of people use it on their Raspberry Pis. Now, in the Raspberry Pi 5, we'll have code exactly like the Raspberry Pi 4, but there's a reference here to NumID somewhere. Okay. Nearly forgot. I did say there was more. Let me briefly show you where the actual sound files are stored in our setup. Root, DockerIOT, Node-Red, data, audio. So this is the directory structure as the Raspberry Pi natively sees it. Data audio is how Node-Red sees it and anything inside Node-Red. But it's the one place, there are my files. All that gubbins at the start of that code was just to, if when you say hello there or whatever, it's just hello there. But to make a file, I put underscores between the words and got rid of any special characters. I should have played you these, they're quite good, but no mind. The other thing you're going to see on this screen here, I keep referring to my CLS function. Here it is running. I thought you might like to compare the two. There is the Raspberry Pi 4, and there is my CLS. You'll see a maximum of 1,800 megahertz Raspberry Pi 4. If I flip over, there is the CLS on the Raspberry Pi 5. So for that and other reasons, the Raspberry Pi 5 is considerably faster than the Raspberry Pi 4. And that is actually the main reason that I switched over. I wanted a little more speed because I'm doing lots and lots of stuff here. Home control, and the Raspberry Pi 4 is just beginning to show delays a little bit slow down. I've got all of my Zigbee stuff, all of my Tasmota stuff, graphing, lots and lots of things going on. It does the job, it works, but I think the Raspberry Pi 5 possibly will give it an edge. The Raspberry Pi 5, incidentally, I'm just using the light version. I have no use for the desktop version at all, so it'll save a little bit of resources there. Anyway, that's it